Today's video will demonstrate how to verify a recursive algorithm using a program trace. Hello, I'm James Helfrich. Recursive algorithms can be difficult to debug because the function calls itself. One way we can track how this works is something called a program trace. This video will review how program trace works and demonstrate how to use a program trace to verify a recursive algorithm. First, let's start with a review of a program trace. Here we have a Swift function which computes whether a given year is a leap year. Now, how do we figure out how this works? We're going to start with a table that has two columns, the two variables on top, year and is leap, and the 0th column is going to be the line number. So execution is going to start here on line number 19. So I'll say on line number 19, the value of year is, my test case be 2000, and my value of is leap year is unknown at this point in time. What line of code will execute next? Well, 21. So line 21, year is still unchanged and is leap is still unchanged. Now, what comes after 21? Since 2000 is evenly divisible by 4, I'm going to skip to line 23. Now, line 23 is still 2000, and is leap is not defined yet. Now, 2000 mod 4 does not equal 100. Oh, it does equal 0. So now I go to line 25. And then from 25, I then go to line 28. Now notice how my line numbers are going to track which line I execute. I'm not going to execute line number 22, 24, or 26 because I didn't evaluate the true in that Boolean expression. Now 28, I'll say is leap is false. And then after that, I'll go to line 30. Now notice that 2000 is in fact a leap year, so I've discovered a bug. So how do we do a program trace with recursion? Well, the trick is we have to keep track of which version of the function we've called. In other words, what are the input parameters? So here, I'm going to create an extra column called parameters and an extra column called a return. And I want to add 7 and 3. So I'm going to call with 7 and 3 as my input parameters. And then I'm going to go to line 20. And see our value 1 and value 2 are 7 and 3. And since value 2 is not 0, I'm going to go into 24, and I'm going to decrement both. I'm going to decrement value 2 and increment value 1. And then I will call add. Now add is going to jump me after the number 29. Now 29, I'm going to have different parameters. So I'm going to put a new column in the parameters. I'm also going to color code it just so it's easier for me to see visually, but you don't have to do it by hand. Okay. And let's see here, 20 is, and then I'll do 24, increment value 1 and decrement value 2, and then I'll call add again. So now I'm going to call add again with 9 and 1 as my parameters. Now 1 is not 0, so I'm going up to line 24, and then I'll go to line 25. Now at line 20, and now 19 again, and so now my parameters are 10 and 0. I'm at line 19, go to line 20, and then, so now value 2 is 0, so I return value 1. So that's my return value. Now, what line do I execute after line 21? Well, since I'm finishing out of this call, I go back to my 9.1 parameters, and I'll return that value, and then the 8.2, and then the 7.3. Okay, let's take a look at another example. This function will take a decimal number called decimal and turn it into a binary representation, 0s and 1s. And I have two test cases, 7 and 42. So once again, I have my line numbers now are A, B, C, D rather than line numbers on the side. I could do them either way. And my parameter is 7. And so my decimal value is 7. And then at line B, I'm going to call my decimal is still 7. And my return value is going to be something plus 1. And so that something means I have to make another recursive call. So now I'm going to call with 3. And then it's going to be something plus 1. And then I'll call 1. And that's going to be something plus 1. And then I'll call 0. Now from line A, now I'm going to go to line C. And that's going to return 0. And now 0 is going to get appended onto this guy. So now it's 0, 1. And then I'm going to finish that call. So now I'm going back to my previous one and be 0, 1, 1. And then 0, 1, 1, 1. Okay, let's take a look at the same problem again now with 42, okay? So 42 is my value, go to line B, and I'm going to do something plus 0. And why 0? Because decimal, which is 42, mod 2 is 0 because it's even. And now I'm going to call binary from decimal. decimal 42 divided by 2 integer division is 21. So my next time through, I'm going to call it with 21. Now, since 21 is odd, I'm going to add 1 onto it. And now I'm going to call binary from decimal. 21 divided by 2 using integer division is going to be 10. Now 10 is even, so I'm going to append a 0 on. 10 divided by 2 is going to be 5. 5 is odd. 5 divided by 2 is 2. 2 is even. 2 divided by 2 is 1. 1 is odd. And 1 divided by 2 is 0. Now, line A, I'm at 0, but since decimal is not greater than or equal to 1, now I go to line C, and I'm going to return 0. And so I'm going to return, and now I'm going to go to return of 0. And so that's going to bring me back to my line from previous one. And I'm going to add 0 onto the 1 from the previous line. And then I'm going to add 0 from the previous line, and then 1, and then 0, and then 1, and then 0. And that's how I'm going to construct the value. Now, the cool thing about program trace is I can always go back in time and see what the given state of the program was, both in terms of its call stack, as well as the value of the parameters and the value of the variables. This is example 16.4 in the recursion chapter of the software design textbook.